Coming to the unsaturated hydrocarbons, first one is the alkenes containing carbon-carbon double bond. So out of this double bond, one will be sigma bond and another one will be the pi bond, and pi bond will be arise due to the sideways overlapping of the p orbital. Coming to the preparations, first one from dehydration of alcohols. Here an alcohol, when treated with aluminum oxide at higher temperature, that is 350 to 400 degrees Celsius, removal of water molecule takes place and the corresponding product will be alkene. So here OH from this CH2OH and hydrogen from the adjacent carbon CH2 group will be removed and a double bond will be formed between these carbon-carbon atom. So it will be the corresponding alkene. The order of the reaction will be tertiary will be higher, coming to the secondary, and primary will be the lower. Let us see the examples. A primary alcohol, that is OH group, is attached to one carbon atom at 75% of sulfuric acid and 140 to 170 degree converted into alkene, while the secondary alcohol 60% H2SO4, it will be converted into the corresponding alkene. Similarly, a tertiary alcohol 20% H2SO4 will be converted into alkene. So the order will be highest for the tertiary, coming to secondary, and least to the primary. One more case, when primary alcohol treated with 75% sulfuric acid, we will get an alkene having double bond here, and it will be undergo rearrangement and forms a corresponding alkene such as 2-butene, which is symmetrical one. So here this is due to the Stacev's rule. The rule says that in the dehydration of tertiary or secondary or tertiary alcohol, when there is a possibility of the formation of two olefins, as seen in the example, hydrogen atom preferentially eliminated from the carbon atom with the fewer number of hydrogens to give an olefin having maximum number of alkyl groups about the double bond. So here about the double bond, considering the double bond, here two groups will be coming on both sides, two alkyl groups will coming, here only one and here three. So it will be symmetrical and it will be more preferentiable. Or the better example for the Stacev's rule is the second one, that is when secondary alcohol, there is a confusion whether hydrogen will be coming from the CH3 or CH2 group. So according to Stacev's rule, the hydrogen will be removed from the carbon atom containing least number of hydrogens, and here from here hydrogen will be removed and corresponding product will be formed. So here secondary alcohol when converted into this one, and the major product will be this one, that is symmetric through the double bond. Next one is the dehydrohalogenation of alkyl halides. Here also the order is tertiary alcohol, coming to the tertiary halide, secondary halide, and primary halide. So when a primary halide treated with alcoholic AOH and heating, the corresponding alkene will be produced by the removal of KX and water. Here also, according to Stacev's rule, the reaction takes place for a alkyl halide. When KOH is here treated with KOH, corresponding alkene will be produced. For a secondary alkyl halide, when treated with the KOH, there will be two products in which the more alkyl group substituted will be the highest lower group, and symmetric alkene will be the major product. So here hydrogen will be removed from CH2 group, which a carbon atom which contains lower number of hydrogen atoms rather than the CH3 group, which is having higher hydrogen atoms. So this product, that is Br from here and hydrogen from here, and a double bond between CH3CH group or CH2CH group will be less preferred here, and the major product will be having a double bond between CH and CH, or the double bond will be symmetrical in the product. Also, according to halide, the dehydrohalogenation for different halogen is in the order. Iodine will be more coming to the bromine and chlorine. Reason is due to the size of the halogen atoms. Next, coming to the dehalogenation of vicinal dihalides. We have two types of dihalides, vicinal dihalide and geminal dihalide. In vicinal dihalide, two halogen atoms are attached to adjacent carbon atom, while in geminal dihalide, two halogen atoms are attached to the same carbon atom. So in the vicinal dihalide, when treated with zinc, alcohol and heating, these two halogen atom will be eliminated as zinc halide, and corresponding alkene will be produced. So here CH3CHBr, CHBr, CH3 and zinc, alcohol and heating, zinc Br2 will be eliminated and corresponding alkene will be produced. Here in place of zinc we can also use metallic sodium for the reaction. The same reaction when carried out in geminal dihalide, we will get a higher alkenes, that is the alkyl halide having, if 3 carbon atom means we will get the product with the alkene having 6 carbon atoms. So here zinc when treated with the geminal dihalide, Zn(X) will be eliminated, and one more this molecule will be attached to the initial carbon chain and a double bond will be produced. So here sodium and ether used as the reagent, similar product will be obtained. Next one is the electrolysis of salts of dicarboxylic acid. For the alkane preparation we are using monocarboxylic acid. In place here we are using dicarboxylic acid, corresponding salts of dicarboxylic acid. So when disodium succinate CH2CONA, CH2CONA on electrolysis gives the corresponding ions CH2CO- and CH2CO- Na+, and at anode this anion combining with electrons and giving the corresponding free radical. From that, two molecules of carbon dioxide molecule will be eliminated and corresponding alkene, that is ethene, will be produced. Similarly at cathode, Na+ will combining with 2 electrons and gives the corresponding Na atom, which again combining with water to give sodium hydroxide and H2. So this is the Kolb's method for the preparation of alkenes.